Section 1.1, Points, Lines, and Planes. In geometry, a point, line, and a plane are considered undefined terms because they are only explained using examples and descriptions. So the first thing we have is a point, and really as a description, that's a location. It's neither a shape, it has neither shape nor size. Usually we say point A, sometimes we'll just say the capital letter. And we see that as a dot with the capital letter. For a line, it's made up of points and has no thickness or width. There is exactly one line through any 2 points. So if you see that green line over to the right, it has points P and Q on it, and we've labeled it cursive letter M, the lowercase letter. So we can call it line M, line PQ, or line QP. Instead of writing the word line when we're using the points PQ and QP to label it, we use this line, this drawn out line above the letters with arrows on either end. For a plane, that's a flat surface made up of points that extend indefinitely in all directions. There's exactly one plane through any 3 points not on the same line. A good example of a plane is the coordinate plane that you're familiar with from Algebra 1 for graphing. So in this case, this could be called plane K, where it's labeled by the capital cursive letter K. It could be plane BDC, because those are 3 points on the plane. It could be any order of those 3 points. So plane BCD, plane DCB, plane BCD, we already said that, BDC. It could be any order of these guys. So as long as you just rearrange them, D, B, C, you could, get a whole bunch of different options. All right. 2 definitions we do want to know, though, are collinear and coplanar. So when things are collinear, that means they are on the same line. Co meaning same, linear meaning line. When we're talking about coplanar, co meaning same, planar meaning plane. So they're in the same plane. So in this example, what we want to do is use the figure to name each of the following. So the first thing we want to do is name a line that contains point K. So here is point K and a line containing it. We see that's this line right here, so we can label that a few different ways. One way is by saying that it is just line A, that lowercase cursive letter A. We could use any combination of 2 of the points on there. So we could call it line JK, or we could reverse the letters and say KJ. We could do line JL. Again, we could reverse those letters and go LJ. We could do line KL. And again, we can reverse those letters. Any of those is acceptable, and I think I covered all my bases there. All right, so for part B, what we're asked to do is, sorry, got a little lost down on the side. For part B, what we want to do is find a plane containing point L. All right, so let's get rid of what's on here, and we want a plane containing point L. All right, so here is point L. And we want to know what plane that is in. Well, it's obviously in this plane given to us. We see the cursive letter B, so we could call this plane B. Oops. We could also refer to this from any 3 points on the plane that are not all in the same line. So we could say this is plane JKM. We could call this plane JLM. We could call this plane KLM. We can also rearrange any of those letters. So KMJ or plane MJK or anything along those lines. If we take a look at example 2, what we're asked to do is name a geometric shape that is modeled by each object. So the first one is a 10 by 12 patio. So if you think you go outside, a patio is usually pavers or cement, and it's really just a flat surface. So that's representing a plane for us. A button on a table, on the other hand, a button is really like a dot or a point, and the table is representing a plane. So this is a point on a plane. When we intersect lines and planes, they form specific things. So the intersection of two or more geometric figures is the set of points that they have in common. So if I have two lines and they intersect, this should be familiar from Algebra 1, right? If we put two lines on a graph, their intersection is at a point. So two lines intersect at a point. On the other hand, if two planes intersect, you can almost think of this as like two walls, right? If two planes intersect, their intersection is no longer a point, it's line. All right, so to draw and label a figure in example 3 for each of these relationships, we're starting with plane R. So it would be a good idea to draw out a plane, and let's call it R. Remember, it's a capital cursive letter. And it's going to contain two lines, AB and DE, and they're going to intersect at point P. So let's draw AB. Whoops. Just keeping my colors from last time. Line AB. We have line DE. Okay, and let's put some points on them to label. So this is line A, B. This is line D, E. And they intersect at point P. And then it says add point C so that it is not collinear with either of those lines. So just anywhere where it's not going to touch one of the green lines. All right, and the next one, QR is on a coordinate plane. So let's get a coordinate plane going. That would be your XY graph that you're used to from Algebra 1. Let's see, 1, 2, 3, 4. 1, 2, 3, 4. Okay. So we want to have the points Q and R. Q is at -2, +4. R is at 4, -4. And those are on line QR. Oops, that is not even a little bit straight. Sorry. Okay. Next, what we want to do is add point T so that T is collinear. So T could be added in between Q and R. It could be on the outside of Q or the outside of R. It's up to you. So if you want to put it in here, if you want to put it over here, it does not matter as long as it's on that green line. Definitions or defined terms are explained using undefined terms and or other defined terms. So space is defined as boundless, three-dimensional sets of points, and space can contain lines and planes. So if we take a look at example 4, we're going to use the figure to answer these questions. How many planes appear in the figure? Well, we can say for sure plane S, but there's another plane that we're not accounting for, and that's the vertical plane that's going to contain those lines that go off of this one. So in reality, there are definitely two planes visible here. Name 3 points that are collinear. All right, so I see that B and C are on the same line, but I don't know another point there. I see A and C are on the same line, but again, I don't have another point. But if I take a look at this line here, I see that A, B, and D are all on the same line. Are points A, B, C, and D coplanar? A, B, C, and D. Well, A, B, and D definitely have to be because they're on the same line, so they're in the same plane. Is C also in that same plane? And the answer is going to be yes. And they're all lying on the plane ABC or ADC. You can label it a few different ways, just using 2 of the letters from the line and C included. And lastly, at what point do lines DB and CA intersect? DB and CA intersect at point A.